To access Kubeflow, just head over to kflow.itech.aau.at, press sign in with Dex, enter your credentials, press login. After logging into Kubeflow, you are greeted with the dashboard where you can have a look at the quick shortcuts. You're able to create a new notebook, upload a new pipeline, or view your previous pipeline runs. You can also see the recent notebooks you implemented. I have a few here, which I will go into a bit later. You can see your recent pipelines, as well as your recent pipeline runs you did on those pipelines. And you can also have a look at the documentation where you are linked to Kubeflow's website, Kubeflow's documentation sites, or KDIP's documentation. Here you also have several different tabs. First of all, notebooks, where you can access your notebooks and create new ones. These notebooks are pre-configured with popular libraries like TensorFlow, PyTorch, and scikit-learn to make it easy to get started with your machine learning tasks. I will get into more detail about that shortly. Then you have tensor boards, where you can access the logs outputted while training your models. Under volumes, you can see the volumes that are attached to your notebooks or additional volumes you created to store data. These volumes are persistent, so they also remain after a notebook restart, for example. Then we have KDIP experiments, which is used for automated hyperparameter tuning. We have kserve endpoints, which allows you to expose your trained data to certain endpoints to allow users to send data for inference to your models via an API, which you can configure here. And under pipelines, you can upload your created pipelines, create experiments, you can configure runs on your experiments, you can configure recurring runs, you can look at generated artifacts, and you can also look at the executions during your pipeline executions. So to start a new notebook, just go under the Notebooks tab, press New Notebook, give it a name. Then you can choose between 3 different notebook types. You have a Jupyter Lab notebook, Visual Studio Code, and RStudio. For each of those, you have custom notebooks. So Jupyter Lab, for example, you have SciPy image, PyTorch, and TensorFlow. You can specify a minimum CPU amount you need, a minimum memory amount you need. You can specify how many GPUs you need, and you can also create a new volume for your workspace. Additionally, you can add additional data volumes by creating a new data volume or attaching an existing volume. Existing volumes can be mounted if they are accessible to the Kubernetes cluster, for example, the login servers. So after you've created your notebook, it is listed here under Notebooks, and you can connect to it via pressing the Connect button. If you click it, it opens a basic Jupyter notebook. I have already some code in here because I will give you a short Hello World example. For this example, we need to import some Kubeflow specific imports. Then we define our Hello World function, and we wrap a DSL component around it. The basic idea in Kubeflow is that each function is containerized, and you pass the variables between the functions by using input and output decorators, which we will see in a more complex example later on. Next on, we define a pipeline where we basically define the flow of the components we previously defined and which component depends on which component. And last but not least, we compile everything into a .yaml file, which we can then download and upload in the pipeline section. So if we execute everything, wait for a bit, we can see we have now got a YAML file which contains the pipeline. Here you can download it and later upload it in the pipeline section. Next up, when you have saved your pipeline.yaml file, you can go over here into the Pipelines tab, go under Pipelines, upload a new pipeline. You can give it a name, like for example, Hello World. Upload a file, you choose the file, and then you press Create. Now you can see a note for each of the steps you have in your pipeline, or each function, or each log you produce, stuff like that. So to use it now, we can create a new experiment, give the experiment a name, like again Hello World, for example. Press Next, then you give your run a name, We have several options in here as well. You can configure a recurring task, a one-off task. Let's for now use a one-off task. A recipient string for our function would be, for example, my name. Then we press start. And now we also generated a run on our experiment, which in turn uses the pipeline we uploaded. So after the run was completed, you see a green check mark here. You can press on the node and then you can have a look at the input parameters again. In our case it was Mario and the output parameter was Hello Mario. So everything worked out well. If we now want to create a new run, we could go under Experiments, Hello World, create a new run, choose the pipeline again, give the run a new name. For example, let's say Max. One off again, recipient is Max, start it again. Now it would run on a new experiment, which we could see under the run step or inside of the relevant experiment. But enough of Hello World, let's look into a more sophisticated example. If we go on the notebooks, I prepared a MNIST demo where I implemented a short training algorithm on the MNIST dataset. So let's connect to this notebook. Here we can see we have all of the relevant imports again. These are just global imports. Imports we use inside of each function have to be defined inside of the function because of the containerization of the program. So next off we define the base image we want to use. And now we go on to the first step, the data loading step. Again, as in the previous example, we have the DSL component wrapper. This time just specifying the base image we want to use, which now is TensorFlow latest. We define the function. Here we get all of the train pickers as output from the function. We import our data set. As I already told you, we have to do the imports we use inside of a function in the function itself because of the containerization. We load the data set and write out the picker data. Next up we have the pre-processing step where we again have the DSL component wrapper. We define the inputs and outputs. So in this case the train pickers from before are our inputs and the prepared or pre-processed training data is our output. We have our inputs again and we do the basic pre-processing steps for training afterwards. So the model training part, we have the wrapper again, then we define our inputs and outputs again. So here are just variables we want to later specify or pass in the pipeline. We have our inputs, our outputs. Here the artifact output will be later used by TensorBoard to display our progress. We have the imports again, we build a basic model and we do some training on it. Now we have the evaluation step where we specify the base image again, and here in the evaluation step we needed scikit-learn, which was not installed by default. So to install it we have to define it inside of the DSL component wrapper as packages to install. In this example scikit-learn. Again we have all of the input and outputs we need. We have our imports and we do the evaluation step. And last but not least we define our pipeline. We give it a name, like for this pipeline I named it MNIST pipeline, and here we define the steps we need to take to go through the pipeline. Like first off we have the data where we use load data, the pre-processing step where we use the function pre-process data. We have the model training step where we use the train function, and afterwards we do the evaluation via the evaluate function. For each function you can define memory limits or request certain amounts of memory as well as CPUs and CPU requests, but this isn't mandatory. You can just do it if you want to restrict the memory or CPU usage of your model. And in the end we just compile everything again and generate a .yaml file. And for this example, I have pipeline, so I have a parameter epochs, which we can then later specify in the pipeline interface. So after we downloaded our new pipeline, we can go again into the pipelines tab, upload a new pipeline, give it a name like MNIST training, upload a file, and create it. I already created it beforehand, so after creating the pipeline, it should look something like this. Here we can see we have many more steps than before. We have the load data steps. We can look at all of the outputs, like our test pickers and train pickers from the first step, which in turn go into the pre-processed data function, which then produces the prepared data for training and testing. All of that goes into the training step, which in turn produces model artifacts and a log. And we can we have the evaluate function, which produces metrics and Scala metrics. So to try it out, we can create a new run. I already created a new experiment. So we choose the pipeline, the relevant experiment, give it a name, like for example, let's say 5 epochs, a one-off experiment. Here we can define our epochs, let's say 5. So after the pipeline has finished, we can see all of the different steps it took. So load data and pre-processed data was cached already because I was running it with different epochs beforehand. So the change in epochs didn't change load data or pre-processed data, so it didn't have to run again. Only train and evaluate was running again. That's seen by the green check mark. So now we can have a look at some of the outputs, for example in the metrics folder. In the metrics folder, if we go into visualization, we can have a look at the matrix that was produced after training. Or in Scala metrics, we can also see some values like the accuracy, loss, and precision of our model. If we now head over to experiments, we can see all of the different runs made on this experiment. Like for example, our 5 epochs run. I also did some runs before, so we can select a few of them. For example, the 5, 1, and 30 epochs, and then we have the option to compare runs. Here we have the option to look at the different scalar metrics between the runs, as well as compare confusion matrices across the runs. So for example, comparing the 5 epochs to the 30 epochs run. And yeah. So if you want to use Kubeflow for your existing machine learning tasks, just remember that you have to split up all of your functions into separate components that can be containerized, and define a pipeline that connects every component together. Otherwise, it's basically the same as writing a normal machine learning script.